Abandoned mines are a big issue in the United States today. There are an estimated 500,000 retired mines in the U.S. alone. The surrounding land and water is contaminated or scarred due to the extraction process of coal, ores, and minerals. So that leaves us with many questions, such as what do we do with these mines, or why is it important to do anything at all? Abandoned mines often come into contact with campgrounds, public lands, recreational areas, and national byways. This close proximity is a risk for exposure from contaminants left from old mines in the soil, water, and air. Acidic drainage from these mines makes the water in the surrounding areas more corrosive. One major problem with leaving abandoned mines alone is that it contaminates surface and groundwater. Chemical pollution from mines is highly acidic and can be rich in heavy metals, which causes a drop in the pH of the surrounding water. Surface runoff that is carried downstream by abandoned mines can lead to black streams and rivers, causing the flooding of roads and residential areas and increases the risk of landslides and erosion. Abandoned mines may pose safety hazards as well, such as open shafts, unstable rocks, decaying supports, high walls, open pits, vertical openings, deadly gases, a lack of oxygen, and there may be explosive or toxic chemicals still inside. The Office of Surface Mining Reclamation and Enforcement is working to limit the number of these disasters. So what do we do instead? One solution is to turn abandoned mines into pump water storage facilities. Pumped storage hydroelectricity is a renewable source of energy. During periods of high electric demand, water is pumped from a lower elevation reservoir to a higher elevation reservoir and then released through turbines to generate power. During periods of low electric demand, water is pumped back into the higher reservoir to recharge it. The water is continuously recycled between the two reservoirs. Some advantages of this process include lower operating costs and flowing water is not required. This is good for locations with droughts or few bodies of flowing water. Some disadvantages include high initial cost, a large amount of water and concrete, and potential environmental harm to the surrounding areas. However, if the process is done with abandoned mines, it eliminates the strain and the effect on the current waterways, thus eliminating the disadvantage. One example of this process is a facility in Norton, Ohio. They are proposing a 15,000 megawatt pump storage hydro project, which would be enough to power about 15 million homes daily. This project will use an old limestone mine which was abandoned in 1976 with a storage capacity of roughly 8,000 acre-feet, or that's about 3 Empire State Buildings. It is estimated that annually this facility will produce about 2 million megawatt hours, which would be enough to power New York City for about 3 weeks. In terms of the triple bottom line, the cost of reclaiming the estimated 500,000 abandoned mines will be expensive, costing the taxpayers upwards of $72 billion. However, once the hydroelectric systems are installed, the only cost will be system maintenance. In terms of the environment, hydroelectric power is self-renewing, sustainable, and converts a source of pollution into a source of energy for the surrounding populations. Finally, in terms of social benefits, covered mines will help improve the overall health of the community as toxins in the ecosystems and water sources will be significantly reduced. In conclusion, abandoned mine reclamation is an expensive process but could potentially save thousands of communities nationwide. A good way to repurpose these mines is through the use of pumped storage hydroelectric power facilities. Although the initial costs are high, the process creates clean, sustainable energy that can benefit both the community and the environment.